In this video, we will do a probability example involving permutations or combinations. So the example says, a dance team has 7 new and 18 experienced members. Find the probability that a randomly chosen group of 6 dancers has at least 4 experienced members. And it also says to don't simplify your fraction that we get at the end of the problem. All right. So this question says that we have 7 new and 18 experienced members. And what we need is a group of 6 dancers with at least 4 experienced members. So I'm going to refer to the new dancers with capital N and experienced dancers with a capital E from now on, just to save myself some writing. So what we're after is the probability that we have at least 4 experienced members. So I'm just going to write that we have greater than or equal to 4 experienced members. So let's set up our fraction for probability. And on the numerator, I need to count the number of successful outcomes. And I have a successful outcome if we have at least 4 experienced members. So the top is going to be the number of groups. And our groups have to have 6 members here. Groups of 6 with at least 4 experienced members. So I'm going to notate that with a greater than or equal to 4 E's. And the way I'm reading this is with greater than or equal to 4 experienced members. I'm just using this notation to save myself a little bit of room. Okay, and on the bottom, I divide by the total number of outcomes. And in this case, all the outcomes I'm looking at are the different ways I could choose a group of 6 dancers. So I'm going to divide by the total number of groups of 6. In this case, those are my outcomes, the different groups I could choose. All right, let's figure out the denominator first, because it's easier. The number of groups of 6 dancers. I'm just choosing 6 dancers from the overall group of dancers on the dance team. And when I do that, the order in which I pick the dancers does not matter. So we're going to use combinations. And how many total dancers do we have? Well, there's 7 new plus 18 experienced, which means there's 25 total members. And to form our group, we are choosing 6 from the overall pool of 25 dance team members. Okay, and if we work this out using our formula for combinations and a calculator, we get 177,100. All right, now let's focus on the numerator. Okay, so this was the denominator, number of groups of 6, and we got what it was. Let's do now the numerator, the number of groups of 6 with greater than or equal to 4 experienced members. I'm going to write 4 E's. Okay, so if I need to have at least 4 experienced members, there's a few different ways that could happen. I could either have 4 experienced members, I could have 5, or I could have 6. So let's consider all of those cases and just add up those values. So I need to count the number of groups with 4 experienced members. I'll just write 4 E's. And if there's 4 experienced members, that means there also must be 2 new members. I'll write 2 N's to complete the group of 6. And then we're going to add that to the number of groups with 5 experienced members. All right, 5 E's. If there's 5 experienced members, that means there's 1 new person. And then add that to the number of groups with 6 experienced members, 6 E's. And in that case, there would be 0 new members. All right, so let me shift this over a little bit. All right, so now let's work out what all of these are. Okay. So what does this equal? So when I have 4 experienced members and 2 new members, I got to choose each of those separately. So I'm going to put a blank space for my experienced members, a blank space for the new members, and then a plus. And then for the next case, 5 experienced, 1 new, I'll put a blank space for the experienced, a blank space for the new, and then plus. And then in the last case, I'm only picking experienced members, no new members. So I just need 1 space for that. And in fact, let's knock the last one out first, just because I think that's the easiest. In that last case, we are choosing 6 experienced members, 6 E's from, well, if I need to pick all experienced members, and how many experienced members did we have total? Well, there were 18. So we'd be picking these 6 experienced members from the 18 E's that we have total. So, and the order in which we pick them doesn't matter, so we're going to use combinations. So we're choosing 6 from the group of 18. So we have 18 choose 6 in that case. And the reason why we're adding these, by the way, is the fact that these sets are all disjoint. They're completely distinct or disjoint cases. So I'm just adding these together. Okay, now let's start at the front maybe. The number of groups with 4 experienced and 2 new members. So let's pick the experienced members first. So now we're going to have to choose 4 experienced members, 4 E's from, and we had 18 E's total. The order in which we pick them doesn't matter, so this is a combination. We're choosing 4 experienced members, so 4 at the bottom, from a group of 18 total experienced members, so 18 at the top, and we have 18 choose 4 ways to pick the 4 experienced members. Now let's do the ends. Well, we are now choosing 2 ends, 2 new members from, and in the problem it said we had 7 total new members from 7 ends. So I need a combination again, and we are choosing 2 new members from a group of 7 new members. All right, and we are going to multiply these 2 combinations together because these are different steps of computing the number of groups with 4 experienced members and 2 newbies. So we multiply when we have different steps or stages to counting the number of elements in a set. And to count the number of elements in this set, I needed to first count the experienced members, the number of ways to pick them, and then count the number of ways to pick the new members. All right, so similarly, for this middle case, I need to now choose, let's do experienced members first, 5 experienced members from, and there were 18 total, from the 18 experienced members. So we'll get a combination again, because order doesn't matter. And this would be 18 choose 5. And this last one is going to be a little bit easier, I think. We just need to choose 1 new member from the 7 new members. So there's 7 new members. I just have to pick one of them. How many ways are there to do that? I actually don't need a combination at all, really. There's just 7 ways. 7 ways to pick one of them to fill this 1 newbie spot. If I did want to use a combination, this would be 7 choose 1. But if I work out what 7 choose 1 is using my formula, we'll get 7. Alrighty, so we have all of these. If we use a calculator to evaluate this whole thing, we will get 142,800. So if I zoom out a little bit, we have figured out the numerator of our fraction. The numerator was this, and we just worked out that it is 42,800. So we are ready to write down our probability of having greater than or equal to 4 experienced members. And we now know the numerator of this fraction is 142,800, and the denominator is 177,100. And this question said we could leave our answer as a fraction. So it would be fine to leave it like this. If I did want to get a feel for, how big is this number, I could plug this into a calculator And this is about 0.8063 if I round it to 4 decimal places. If I convert that to a percentage, I multiply by 100, and I would get 80.63%. Okay, so that's a pretty high chance, about an 80% chance, that when we pick a random group of 6 dancers, that there's going to be at least 4 experienced members in it. So in terms of our goals for this section, we finished our second goal. We've talked about how to compute probabilities using things like multiplication, permutations, and combinations. Even though permutations didn't technically show up on that last problem, we had multiplication and combinations, we could envision how permutations might show up. If we needed to count the number of outcomes and the order did matter, we'd use some permutations.